Hello and welcome to another GCSE revision video, and in this video we're going to be looking at the area of a triangle. Now we know that the area of a rectangle is just length times width, but we can also call the length of a rectangle the base, and we could call the width the height. And we could say then that the area of a rectangle is base times height. Now if we chop a rectangle in two along one of its diagonals, we have ourselves a right angled triangle. And so it's very easy to see that the area of that right angled triangle will be a half of the base times the perpendicular height. And we know the height is perpendicular to the base because it's a right angled triangle. Now we could apply this same rule to pretty much any triangle. If we drop a line from one of the vertices to the base so that it's perpendicular, we can then take the half of the triangle or the portion of the triangle that is left, and we could actually rearrange it to form a rectangle. I'm afraid you'll have to do that in your head. I haven't got any fancy graphics to show that. Okay, with a little playing around with my recording software, I think I've managed to show how to visually demonstrate that the area of a triangle is half the area of a rectangle. Okay, I hope you found that visually convincing. Now if the area of a triangle is a half base times perpendicular height, we could actually calculate that perpendicular height if we remember our SOHCAHTOA, that the opposite is equal to the hypotenuse times the sine of the angle. Well, in this case the perpendicular height is opposite angle C, and the hypotenuse is side B, and we've labelled the base side A arbitrarily. So the area of this triangle is a half of side A times side B times the sine of C. So the area of any triangle is just a half AB sine C if we follow the convention that the length is opposite the angle of the same letter. Okay, well, so much for the theory. Let's have a go at putting that into practice. We've got a triangle here, and we're given two lengths and the angle in the middle of those two lengths. And we're told that one length is 6 centimetres and the other length is 10 centimetres, and the angle is 30 degrees. And this time we're trying to get the area of the triangle. Well, we don't have the height of the triangle, so we can't use half base times height. So we can use the next best thing, which is a half AB sine C, where C is the angle in the middle of lengths A and B. So this is a half times 6 times 10 times sine 30 degrees. Well, a half of 6 is 3, so that half can cancel out and that 6 can become a 3. But sine 30 degrees is a half, which we know from our unit circle. So that's also a half, so this 10 can become a 5. So it's actually just 3 times 5. So the area is equal to 15 centimetres squared. Okay, in the case of this triangle, we're given the base and we're given the height, but we're told nothing about the other two sides and we're not given anything about the angles. So in this case the best formula to use is area is equal to half base times height. So the area is equal to a half of 20 centimetres. Let's try and make that look like a 20. Times 10 centimetres. So the area is equal to 10 centimetres times 10 centimetres. Well, 10 times 10 is 100, and centimetres times centimetres is centimetres squared. So the area is equal to 100 centimetres squared. Okay, I hope you found that helpful. Don't forget to like, comment and subscribe. And if you're taking your exams this year, I'd like to wish you all the best with your revision and all the best with your exams. And I look forward to seeing you in another video.